Hello, my name is Wilmer, and today I'll be showing you how to do an AP chemistry problem. Today's problem is a 0.150 gram sample of solid lead 2 nitrate is added to 125 milliliters of 0.100 amps of sodium iodide solution. Assume no change in volume of the solution. The chemical reaction that takes place is represented by the following equation, and this is our equation right there. First, we are asked to list an appropriate observation that provides evidence of a chemical reaction between the two compounds. So this is our chemical reaction equation, and as you can see, when you combine PbNO3 with NaI, you get a product which is PbI2, and that is a solid, which means it's a chemical reaction. Next, we have to calculate the number of moles of each reactant. So first we take 0.150 grams of PbNO32 and divide it by 331 grams of PbNO32, which is the molar mass of the compound, to obtain the number of moles. And when we do that, we get 4.53 times 10 to the negative 4 moles of PbNO32. To find the moles of NaI, we use this little equation, which is volume times molarity, to obtain the moles. First, we need to convert the 125 milliliters given to us in the problem to liters, and we do it here. Then you multiply the molarity, which is 0.100, and when you do that, you get 1.25 times 10 to the negative 2 moles of NaI. Now we need to identify the limiting reactant and show the calculations to support our identification. To find the limiting reactant, use stoichiometry to obtain the moles of NaNO3 reacted by PbNO32, which is right here, and the moles of NaNO3 reacted by Ni, which is right here. And as you can see, the moles of PbNO32 is used up first, compared to the moles of Ni. So our limiting reactant would be PbNO32. Next, we have to calculate the molar concentration of NO3 minus in the mixture after the reaction is complete. To find the concentration of NO3 minus, you use the equation for molarity, which is moles of solute divided by liters of solvent. In this case, we have 9.06 times 10 to the negative 4 moles divided by 0.125 liters. And when we do the calculations, we get 7.25 times 10 to the negative 3 molarity of NO2 3 minus, which is the concentration. Finally, we have to circle the diagram below that best represents the results after the mixture reacts as completely as possible. So, the diagram that best represents the reaction is this one, the farthest to the right, and it best represents the reaction because it contains PbI2 as a solid, which you can see right about here, and it also contains spectator ions Na plus and NO3 minus, which are right there and right there, and also some of the I minus ions because of the excess amount of Ni in the reactants. So we can see the I minus ions, and yeah. So this is how you solve this particular AP chemistry problem. Thank you for watching.